Hello, everyone. All right. So before we get started, do you guys have any questions over the material from last week? All right. Well, we've got a wonderful topic tonight, and actually, it is one of the last topics we're going to introduce from this point forward in the course. After we complete this topic, we'll just be reusing the topics that have already been addressed to achieve different results. So it's kind of good news that, after tonight, you will have learned all the basic constructs, and then we'll just rearrange them to do different things. So, all right. So I'm just going to go ahead and get started. But of course, if you guys have any questions, please do not hesitate to jump in or comments. All is good. All right. So we've already talked about, no, we did not. Sorry, I'm getting my classes confused. So today we're going to do the random class, which allows us to do random number generations, talk a little bit about the BlueJ debugger, arrays, array lists, and regression testing. So we're going to cover all of these concepts today. Okay, so the random class, this is a class that has to be imported. So similar to the scanner class that you use to accept input off of the console, where you have to import the scanner module before you can create scanner objects and use them. The same happens with the random class. You have to have an import Java util random statement up at the very top of your program in order to take advantage of the random module and create random objects and then call accordingly any methods associated with the random class. So what it does is it generates random numbers. Now these are what's called a pseudo-random number. Any guesses as to why it would be called a pseudo-random number? Right. It's the random number class, or this random class was written by a person, right? And so if it's written by a person, what they've done is they've created some hash algorithms to try to generate random numbers. But because there's an actual algorithm that's been written to generate the number, it's not truly random. Somebody could hack in, figure out the hash algorithm, and then generate the exact same number. So it's about as random as we can possibly get, but it's not truly 100% random. Okay. So these random numbers that are generated, or these pseudo-random numbers that are generated, are used in things like password encryption. So when you get those, when you don't specify a password, or when you want to reset your password and they send you this ridiculously long, weird, bizarre password. So a random number generator would be excellent for producing something like that. Definitely in games, so it could be card games or other sort of games like blackjack to generate random cards when you're dealing out cards, dice games, those sorts of things, and then also simulation. So, when you're trying to just run a simulation. I also have used the random number generators, or the random class, in where I work at. So I remember I work in a health center, and we need to do monthly audits of the charts to make sure that the providers are correctly coding and documenting in their charts. So we don't look at all of the charts, but I think we choose 15 per provider. So I use a random number generator to kind of randomly order the charts and to choose out the ones for each provider. So it's also useful in those types of situations. Okay, so again, you have to import the module before you can use it. So you'll have an import statement up at the top of your program, at the very top, before even your public statement for your class. And then you have to create the object. So the object is, the class is random, and of course the constructor is also random, and then you can call it whatever you want to. So I just called it generator here, but you can call it whatever you want to. So standard format for calling the random number generator. Okay. Then we have different methods that will generate floating point numbers. So there's the next dot double, which will generate a floating point or a double number, but the value is just going to be between 0 and 1. So there's no explicit parameters provided for this particular method, but it will generate numbers from 0 up to but not including 1. So like 0.89, 0.7654, and so on. So it's just going to generate numbers between 0 and 1, and then you can actually manipulate those to get whatever numbers you need. The next integer, on the other hand, you will specify a value there, and it's going to generate from 0 up to but not including that number. You know what, Owen? I do not know, but if we have time at the end, I'll look up the Java docs and we'll find out. I haven't had much cause to use the next double. Primarily, it's the next integer one is what I use, but we'll take a look at that. Great question. All right, so the integer one works similar to like the substring where the second value is exclusive, right? So this is how it works. It's you give it a number, it's going to always start with 0 and go up to but not include that number. So if we specify 100, it's going to give us from 0 to 99 are the valid values that you can use. Now you can manipulate this however you want. So let's say we wanted to simulate a roll of the dice. All right, so we would create, well, first we import our module, right? So we import the random module, then we create our random object, and then we call the next integer, giving it a value of 6, which is going to give us numbers from 0 to 5. And if we add 1 to that, it gives us from 1 to 6. And so that can then simulate a roll of the dice. So you manipulate in that manner by adding to it or subtracting from it or multiplying, whatever it is that you need to get the range of numbers that you want. All right, so that was the random number generator. Do you have any questions on the random number generator? It's pretty straightforward, really. It's just a matter of knowing how to manipulate the output to get the range of numbers that you want. All right, so hang on to that decimal number and we'll get it. All right, so the debugger. So there is the BlueJ debugger, and I'm pretty sure that I talked about that before, but I didn't really go into a lot of detail because usually at the beginning of the class, people think that the debugger is actually going to fix their programs, and that is not the intent of the debugger. Okay, the debugger is not going to fix your programs. It's not even going to find the errors for you. But what it is going to let you do is step through your code one line at a time, taking a look at the values of your variables as you execute each line. So you execute a line and then you can see what the values are in all of your variables, and then execute the next line and see what all the values are. So it lets you see how your program is executing. So you know exactly what statement you're on because you'll see it, and then you'll see what the values of each of your variables are. Based upon that, then you can say, wait a minute, that's not what I was expecting to happen here, right? And then you can take a look at your code and you can see, okay, yep, that's why it's going on. So the purpose of the debugger is not to fix your program for you. It's not to tell you, oh, here's your error right here. It's to let you see your code execute line by line and see how the values of your variables are changed. All right, so in a debugger, what you'll do is you'll set a breakpoint. Let me open up something different. Close. See if I have something out here that's compiling. All right, so here's just a simple class. So what you'll do in your program is you set a breakpoint so that the code stops so you can see exactly what the values of your variables are. Now, I'm not sure if I have anything great in here. Here we have a constructor. So I can set a breakpoint by you just click on the line number here, and you can see, I don't know if you can see that little teeny red, but we've got a little red stop right there. Then I can compile and it set that breakpoint. So whenever I call that particular constructor, it will come in here, and when it hits that, it will stop. So let me see if I actually have, yeah, I do. Okay, so let me compile this guy and run him. So when I run the program, When it gets to that point, it stops the execution, highlights the line that I'm on, so you can see it stopped right at the first point. It opens up this little window here, and inside of here, I can see what each of my variables are. So I can see that my instance variable dog name, dog breed are both set to a null value. My dog age is set to 0. I have local variables, which are my explicit parameters here. So I can see that this in name contains the value Fido, in breed contains poodle, in age contains 3, and then I can step one line at a time. So I can just step to the next line, and you can see it jump down to dog breed, but you can also see now that this first line executed, so my instance variable dog name now contains the value Fido. And I can step again, okay? And now I've completed the execution on this line, so dog breed now contains a value of poodle, and I can step again, and now this dog age one executed and it contains a value of 3. And I can keep stepping one line at a time through things as it executes. So now I'm actually in this program, so you can see I finished that line and now I'm right here. And I can see what different instance variables contain. So this one actually says temp dog contains an object reference. I can double click on it and it'll open up, and I can see that the dog name is Duke, breed is unknown, and it's a 0 here. So I'm getting dog 1. I'm going to get the name of dog 1 so I can actually see what temp dog contains. That was this one up here, dog 1. So dog 1 contains Fido, poodle, and 3, all right? And this would just be the arguments up here, which don't contain a value. But I can keep stepping through until, so this set dog 1 equal to Susie, so I can actually click here and see, now it's changed the value to Susie, and so on until I eventually get to the end of the program, at which point I can terminate. Now, if any point in time you're running through your program and you're like, oh, there's my problem, you don't have to manually step through line by line. Let me run it again. So you can run it again. It's still, my breakpoint is still in there. If I'm like, oh, I get it, here's my problem, you can just do a step into or continue and it'll just finish executing your program, and then you can just terminate and you're all said and done. Okay, if you want to get rid of it, you just click again on your breakpoint and it'll go away, and then you recompile, and then when you run your program, it will just execute top to bottom and you don't have to worry about it. So the debugger is a great tool. Okay, it lets you walk through your program line by line however you want to and see what the values of your variables are, but it's definitely not going to fix your program for you, and you need to have a little bit of understanding of what your program is doing. And so that's why I didn't really introduce the debugger at the beginning of the class, just because at that point you don't even really know what's going on with your code, so seeing the variables and things is not going to be helpful, right? You have to have a basic understanding of how your code is functioning before walking through it line by line is actually helpful. Okay, so yeah, click on the line to set your breakpoint and compile, and then when you reach the breakpoint, the debugger stops and you can see the different values and you can step through line by line. All right. All right, and then of course the object is go back to your code and fix your problems. All right, so questions on the debugger? I can see somebody typing, so that's why I'm pausing here, but. Yes, Owen, and we will actually, I think the arrays will help you here. So you can actually do a random string from a list. I mean, you can definitely do something, you know, are you thinking like from Python, the random choice? Is that what you're thinking about? Let's see if we can pull up the Java doc for random. See, I can tell that your interest is piqued with this random class. Oh, very cool. float, integer, long. It does not look like these are all the methods. They all involve just a number. Pseudo-random numbers. So this particular random class only returns numerical values. See if there's anything for random strings. No. So I think they're just going to use it to generate a random number and then pull stuff out. Okay. So we'll talk about that more at the end, all right? But yeah, I mean, there's always ways around things. So it doesn't look like the random module itself, but there may be ways to do it differently. All right, so we're going to move into my favorite topic, which is the arrays and the array lists. This is an amazing construct, and once you've embraced it, you guys you'll love it. It might be a little confusing at the beginning, but it is awesome. All right. So up till now, when we've been defining variables, we needed to define one variable per each entity, right? So if let's assume we have this classroom and I have the potential of 30 students in the classroom, I would have to define 30 variables, one variable for each possible student in the classroom. So I would need to define string stu1 and string sub2 and string sub stu3 and so on, clear up to string stu30. Okay, so this is what we have had available up to this point. Okay, so if I wanted to write a program that would allow me to manipulate the students in that classroom, I would have to repeat those lines 30 times, one for each variable. So I have to say enter the name of the student and then receive that into stu1, and then enter the name of the next student and receive that into stu2. And I would have to repeat this section of code 30 times. So now I have 30 lines defining the 30 variables, and now I have 60 lines to do these two statements, one for each of my variables. Okay, so now I'm up to 90 lines that I've defined for these 30 variables that I'm going to have. And you can see it's making my program exponentially large at this point because I have to duplicate it every single time for each possible variable of 30 variables. And because, we're all inherently looking for shortcuts, we're going to do a copy paste to do this, and then we have the likelihood that we miss, that we forget to change something from a 1 to a 2 when we're numbering and so on. So it's error prone as well. So it's not efficient. 30 variables, 30 times the number of lines for processing. We have a ton of duplication of code, the possibility of errors with duplication, and because they're so long and there's so much duplication, it's very difficult to modify as well as to debug if there's an error. Okay. So with those 30 different variables, they're all going to contain a different value, or they all represent a different student, right? But they're all a student. So even though one might be named Fred and one might be named Sam and one might be named Joe, they're all students. So the type of entity that they are all the same. There's just a different value, a different makeup for each entity. So what the Java developers, and actually not just the Java developers, arrays have been around even since my COBOL days, and I imagine since Fortran and BASIC way back. But what they've developed is this construct called an array. And rather than having to define 30 different variables, one possible variable for every single entity that we have, instead you define one variable for the entity type of student and you divide it into however many elements that you would need. So we would define one entity, student, data type string, and we say it's going to be divided 30 times. So we have one construct, but 30 different students represented in that one construct. Okay. So if we were defining our array in Java, this is how it's going to look. You're going to give it a data type with an open and closing square brackets, and that's the signal that this is an array. So this is going to be an array of whatever that data type is. Then you're going to give it a name, whatever it is that you want to call it, equals new, because we're constructing this, right? It's just a special type of a construct, equals new, and then that same data type again, but now this time in your square brackets, you're going to put the number of elements that you're going to be in there. So in the example we were just going through, if I'm storing the student name here, I would say string with my open and closing square brackets, so not curly brackets this time, but square brackets, stu equals new string and then 30 inside of the square bracket. So this says I'm defining an array, it's data type string, I'm going to refer to it by stu, and inside of this there's going to be 30 individual elements. Okay? Now, an element is a storage location in the array. So if you need a visual picture, think of those, those daily pill strips that say like Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, right? And how you can pop up the tab on each one of those little things and you can put pills in and then you can take pills out. Think of that strip, that whole strip is your array. And each one of those little boxes in the pill bottle is an element or a storage location in that array. And yes, Karina, you are 100%. It starts with element 0. So if we have 30 elements, the elements are numbered 0 up to 29. Okay? Each element has a unique number or a subscript, and so it's real common to say stu sub 1, stu sub 2, stu sub 3 to refer to the subscript of the element. So that's real common language. The first element position is always 0. The last is always 1 less than the length. Okay, and I think that covers all the things on this particular slide. All right. Okay. Arrays are fixed at the time that it's declared, and it cannot grow. Okay, so if we declare it with a size of 30, it contains 30 elements, regardless of whether I only have 15 students in the class or if they're overloading the class and they're trying to put 35 in there. If I define it as a size of 30, that's where it's stuck at. Okay. If I want to add a value to the array, I'm going to give it the array name, and then with square brackets, I'm going to put the position in here and then set that equal to the value. So for instance, stu sub 5 equals Fred. And so element position 5 will now contain the string value of Fred. And if I declared it as string, I can only store string values in there. All right? If I want to retrieve a value from the array, it works the same way. I'll say whatever my variable is equals the name of the array sub and then the element position inside of here. So for example, temp name equals stu sub 7. So whatever value is in element position 7 will now be placed into my stu name variable. Okay. There is an attribute. So an attribute would be like an instance variable. And so the length attribute tells you the number of elements for which your array was defined. So the length element is not going to, the length attribute is not going to tell you how many of your elements contain a value. It's going to tell you how many elements have been defined in the array. So if I declare my array with 30 elements, it's going to say, my length will say 30, even though maybe only 15 of them actually contain a value. It doesn't tell me how many have been populated, but the maximum size of my array, so how my array was defined. And so to call that, oh, and I misspelled it there, sorry about that, integer stu length equals stu dot length. Okay, so Matthew, did your question get, you figured it out, or? Okay, because he's asking about type mismatches. If you try to assign it, it's going to cause an error. If you try to put a number into a string, it will actually, you'll get a syntax error because you'll get a type mismatch error. Yeah. All right. Now with arrays, the really key thing is to remember the boundaries. So the lower boundary of an array is always 0 because that's the first element position in your array. The upper boundary of the array is the length of the array minus 1. So in the case of our student array with 30 elements, the lower boundary is 0 and the upper boundary is 29. So it's 30 minus 1, which is 29. So a real common thing to encounter is an out of bounds error where you're trying to access an element position that doesn't exist. So you most likely it's an upper boundary error is what you're trying to get because your lower boundary is 0 and rarely are you going to give it a negative number, but it's real common to maybe give it 30 until you get used to it goes 0 to 29 as opposed to 30. So it's real important when you're checking things to double check the boundaries of your array to make sure that you don't exceed the boundary. Yes, that would, so we have here stu sub 30 equals ned. That would definitely give you an out of bounds error because you're trying to access an element position that does not exist. Nice example. Okay, so here's an example of an array. So we declare our array with data type integer, integer with our open and closing square bracket, hours equals new integer sub 3. So there's going to be 3 element positions in our array of hours, 0, 1, and 2. Okay, and we set hours sub 0 equal to 40, and you can see here it contains 40. Hours sub 1 equal to 20, and you can see here is 20, and hours sub 2 equals 15. And then we can call integer hlen equals hours.length, and this will actually contain a value of 3 because we were defined with a size or a length of 3 up here. Okay. So if we go back to our example with arrays, we declared 30 element positions, right? Stu sub 1 up to stu 30. This was before arrays. And we printed out, enter your name, and then we received your input from the console. So that's 30 lines up there, 60 lines in here. And if we were to say if stu1 is not equal to an empty position, this would be 30 times as well. So if we look at what we have here, we're defining our array, strings with the open and closing square brackets, stu equals new string sub 30. So we did eliminate 29 lines there. But down here, we're doing a system.out.println enter name, which matches, and stu sub 0 equals inline, and then we would repeat this for all elements 0 through 29. So that's exact same number here and the exact same number there. So although we saved 29 lines, we haven't saved a significant amount of lines yet, but we're about to. Okay. So if we look at this print statement where we want to print each element in the array, we have system.out.println stu sub 0, and then stu sub 1, and then stu sub 2, and then stu sub 3. So if you take a look right here at the element positions and you go clear back to kindergarten here, and the teacher writes these numbers on the board, 0, 1, 2, 3, and asks you, class, what am I doing here? Think kindergarten, don't think fancy computer stuff. What would be your answer way back then if the teacher just writes 0, 1, 2, and 3? Yeah, exactly. You're counting, right? 0, 1, 2, 3. Do we have a loop that works well when you are counting? Yes, the for loop. I'm going to get to your question, Matthew, so just hang on right there. All right, so the for loop is perfect for counting, right? So we can say for integer I equals 0, I is less than the length of my array, right? So less than, because if my length is 30, less than would be 29, right? Increment by 1, and now I can do system.out.println, enter your name, and then stu sub I equals in.next line. Right? So I can just put this, instead of putting the actual element position in there, I can use a variable that contains my element position. And so now those 60 lines that did this is now 5, and 2 of which are an open and closing curly bracket. So now I've eliminated, before with my declaration statement, I eliminated 29 lines. Now I've eliminated 55 lines with this loop. And it doesn't matter at this point whether my array contained 30 element positions or whether it had 100 element positions. It's the exact same. It's these 6 lines, the 1 line to declare my array and then these 5 lines to accept input. Whether it's an array of 10, array of 100, array of 1,000, these same lines would process the array. So now it's got incredibly powerful. Yes, there is going to be a cap on an array, and it is going to be, I don't exactly, the number is not coming to me, but it's going to be a multiple. It's going to be, a multiple of 8 is what it's going to be. So a lot of times, like as far as like nested if statements and nested loops, the maximum number of nested if and loops is 256, which heaven help us if we would actually do 256 nested if or loop statements, right? But that's a multiple of the bits and bytes. So it's going to be some number like that. But I can't say that I've ever encountered it. But yeah. Okay, so Matthew was asking, can you increment an array? No. And once an array is defined, its size cannot be changed. Now, what you can do is you can create a brand new array. So here's how that would look. Let me pull up my notepad here. So let's say we determine that our array is, like we're adding names to it and we're like, oh, my array, and in your program you take consideration. So maybe you're like, you have some if statement that says, oh, I'm trying to add beyond the end, so change my size. So you might actually define a public statement that returns a string array, right? Public string that says increase size. And it takes in a string array of in array here, okay? So it takes in array, and then it or maybe it increases it by 1.5 times and then returns it. So here's what you would have to have. So we've declared this array, this in array up here somewhere, and it's, say it's 30 elements. Well, in here, what I would have to do is I would have to define a whole brand new array, string here equals new array equals new string, and in here I would do in array dot length times by 1.5, and I would need to round this too. Okay, so so I would probably round this. So I would do math dot round also, because you can't declare an array of size, like 32.5 kind of a thing. So I would define a brand new array in here that has, now it's 1.5 times the size. And then I would do a for loop for integer I equals 0. I is less than in array dot length I plus plus. And then I would just loop through and I would say new array sub I equals in array sub I. Okay, and then I'll end my for loop. And when I'm all said and done with this, I just return this new array that I've just created. So you can see this took a little bit of work, right? I'm going to have an array. I'm going to have to keep track. Am I running out of room or not? And if I get to the point I'm running out of room, I'm going to have to call something or write some code to increase the size of my array, and then copy everything from the old array into the new array, and then return this new array that I've created. And then in my program, I'll replace the one with the other, is what's going to happen. So don't worry, you guys don't need to know how to do this. I'm just trying to show you there's a lot of work involved. Okay. This is also, okay, so I'm going to, and hold that thought of how much work that is, because I'm going to show you like a much better way, all right? So here is how we would retrieve data from an array. So again, we can have a for loop, I equals 0, I is less than the length, print out the name, and then print stu sub I. So we can, the previous one allows us to change the value of an array, and this allows us to retrieve it and then do things with it, produce output with it. Okay. Now, one of the disadvantages of the array, as we just saw, is they have a fixed size. So it could be filled up and we need more room, and that's a problem. We're going to need to find a way to increase it, or it may only be partially full. And so if it's partially full, if we're doing things like we did here, we're still processing, so we would put like Fred, Sam, Joe, null, 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 right? Because some of this is partially full. Maybe only the first 5 are populated and the last 25 are not. And so it would print the first 5 names and then null, 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 and we wouldn't want that. We have to deal with the fact that they're partially full. And what you can do to help you with that is you can use a counter variable that keeps track of how many elements you've added into the array itself. And so this is what it looks like. So you can have you can call it whatever you want to. I'm calling it next position equals 0. And so what this tells me is 2 things. This counter is going to serve 2 purposes. It tells me how many elements are currently populated in my array. So when I first create it, 0 elements are currently populated. And it tells me the next empty position in my array. So there's 0 elements, and my next empty position is position 0. So if I wanted to add something new to it, I need to put it in position 0. Okay, so here's how this would work. We would define our next position, set it equal to 0, and then as soon as we populate, we would populate next position. So this is stu sub 0 equals Fred, and then we add 1. So now next position contains a value of 1, which tells me 1 element in my array is populated, and the next empty element position in my array is 1. Okay, are you guys following that? Do you see how every time we put a value in there, we increase it by 1? So it says, and that's how many are populated, and that's my next empty position. Okay. Now, with the other limitations for the array, so that all works great, but with the other limitations with the array, so obviously you saw if it filled up, you have to manually increase it. Also, if we wanted to insert something into the middle, so maybe we are inserting names into our array and it's all alphabetical, and then a new student adds and we need to insert it in the middle, you have to manually shift everything over to create that empty spot in the middle and to put your name there. Likewise, if we wanted to remove something from the middle, maybe a student dropped out of the class, we would have to manually shift everything from the right to the left to take up that empty position. So there's a lot of limitations when it comes to arrays. A fixed size, so it's not, it could be too big, it could be too small, and we have to keep track of what elements are actually populated, inserting into the middle or removing from the middle. It all takes a lot of manual work. So this construct is, well, I had not experienced it in COBOL or any of the older languages, so my first exposure to it was in Java here. So what Java did is they came up with a construct called an array list. So this construct expands the array, so it's actually written on top of an array. And so it uses all the functionality of an array, but there's elements associated with it. And so an array list will grow and shrink as elements are added and removed. It will let you insert or remove from the middle, from anywhere, without requiring you to shift things over. And is there something else? I think those are it. So you can retrieve from the middle, you can do all of the things that you can do with the array list, but it's got a lot more flexibility. So it only is as large as exactly as you need it. So if you put 0 elements in it, it contains a size of 0. If you add 1, that has a size of 1. If you add 100, it has a size of 100. If you add 29, it has a size of 29. Okay. Now with the array list, that's different. The array is a default construct, so it's available to you no matter what. But if you want to use the array list, just as you did with the random, you have to import it. Okay, so it's import java.util.ArrayList. The other limitation is an array list can only store objects, so it cannot store any primitive data. So you cannot store integers, doubles, characters, or booleans in an array list. It has to be an object, no primitive data. Okay, The format for defining an array list is slightly different than what we've seen so far. So it starts, because we're creating an object here, it starts with our class array list, but then you're going to have the greater than and less than symbol, and inside of that you're going to put your data type. So if you're creating an array list of string objects, you can put string in there. If you're creating an array list of dog objects, you can put dog in there. So whatever the data type is, not primitive data, however. Then the name of your array list equals new. Array list is your constructor array list, but again with that data type in the greater than and less than symbol, and then an open and closing parentheses for no explicit parameters. Okay. So here's how that would look with string data. Array list substring stu equals new array list, and then you've got your string and your open and closing parentheses. Yeah, but the final was 4 weeks away, so you're going to get lots of exposure to the array and the array list. So don't worry. We will be using them a lot. All right. So defining an array list with data type string, a name of stu, is going to create 0 elements at creation. Okay. Now the array list comes with a bunch of different methods. When we were using the array, you had direct access to the elements, so you just went right to whatever element you wanted to retrieve your information. But with the array list, you have to use one of its methods. So it has a .add method, and you can do a .add and then just supply it a value, and it's going to add it on to the end. Or you can do a .add with a position and then a value, and it will insert it in the middle at that position and shift everything else down. So I could say stu.add Fred Smith, and it will add him on to the end. Or I could say stu.add 4, comma Fred Smith, and it will insert him into element position 4, and what was in 4 will be moved to 5, and what was in 5 would be moved to 6, and so on, shifting everything down one. Okay. There is the get method. In the get method, you're going to again provide a position, and this retrieves whatever object is at that element position. So string sname equals stu.get7, and it will retrieve whatever is at element position 7 and put it into your variable sname. There is the set method, which will allow you to change an object. So again, it's .set with a position and a value, and so it will change whatever object is at that specified value to your new, or at that specified element position to this new value. So if we had stu subset 4 Fred Smith, whatever is currently at an element position 4 gets replaced with the string object Fred Smith. Okay, and then there's the remove method. So again, this is going to delete an object at whatever element position you specify. So if you say stu.remove 7, whatever is element position 7 gets removed, and what was an 8 now becomes 7, and 9 becomes 8, and 10 becomes 9, and so on. If you try to do any of these things on element positions that don't exist, you will get an out of bounds error. And the last method is the .size. So this returns the number of elements in the array list, and different from the array, where the array is the length attribute, right? And it tells you how many potential elements you have. The array list will tell you exactly this is how many elements are exist in my array list. Okay, so integer a size equals stu.size. That's awesome. I'm glad that, yeah, it's kind of like add, set, get, remove, and size. Yep, they are very straightforward. Yes, exactly. All right, so you can use an array list in your for loop just like we did with the array. For integer I equals 0, I is less than stu.size with your parentheses here because you're calling a method, I++. And then the same print line, enter your name, stu.add in .nextLine or stu.set sub I in .nextLine. However it is that whatever it is that you're doing. Okay, retrieving a value, the same loop, and the student name is, and then a stu.get sub I. Okay. All right, so let's compare these two side by side because they actually both have their strengths, right? So if we were defining an array, both of data type string. So it'll be string with the open and closing square brackets, stu equals new string, and then we give it our length, right? So in this case, 30. An array list, we have to import the module first up at the very top outside of our public statement. And then it's array list with the greater than less than string. So your data type, stu equals new array list. And again, greater than or less than with your data type. And then the open and closing parentheses, because this is a constructor that we're calling. And remember, methods or constructors always have those open and closing parentheses for explicit parameters. In this case, there just aren't any explicit parameters. So this is how you define the array. This is how you define the array list. Okay, if you're getting the number of elements, stu.length will tell you how many elements are possible in the array, but not how many are populated, right? And it's an attribute, so no parentheses here. It's not like the string.length, which tells you how many characters are in a string. This is actually an attribute, so no parentheses. This is the one case. Remember, encapsulation, we're always supposed to define our instance variables as private. This is the one case where an instance variable is defined as public, because an attribute is an instance variable. All right. For the array list, it's stu.size. Okay. When you're setting a value in an array, it's stu sub whatever your element position equals the value. In an array list, it's going to be stu.set. You're going to give it a position and the value, or if you're just adding to the end, stu.add. And it will add to the end and increase your size by 1. In this case, it just changes an existing value. In this case, it actually adds on to the end of the array list. If you're retrieving a value, it's direct access for the array, so string name equals stu sub 5. If you're retrieving it for an array list, it's going to be string name equals stu.get sub 5. So the other thing to keep in mind is in our array, it's always the square brackets. In the array list, it's a method call, so it's parentheses. Yes, you can add with the, see if I go back here. I'm almost there, I think. Nope. All right. It's the add position and then the value. Yep. All right, if you're removing an element, you could say stu sub 5 equals null, or so null is no value, or this gives you just an empty. These are not the same, by the way. This gives you an empty string. It doesn't, it just removes the value, but not the actual element position. So you could end up with an empty spot right in the middle of a group of data. Versus stu.remove sub 5 actually removes the element and reduces the size by 1. So here you're going to have to manually shift over if you want to recoup that position, but here it will actually shift everything over for you. Oh, I thought I had more stuff in there. I feel like I'm missing some things here. All right, so no, -1 will not remove the last element. It's because the last element in the array list is going to be stu sub size -1. So you could do a remove, stu.remove stu sub size -1 to get rid of your last element. Because you have to actually give it, okay, yep. All right, so like I said, I feel like I'm missing some components here, so I'm not sure. I should look and see. But anyway, so students at this point, students are always like, well, why would I ever want to use the array when the array list does all that work for me? All right, so admit it. Who had that thought going through their mind? Well, primitive data types is one thing, although Java does provide a workaround for that. So excellent. Oh, and that's great. So the reality is the array list sits on top of an array. Okay, so in 121, you will actually write the code for the array list if it's still the same as it was. So the array list actually sits on top of an array, and does all the things that I've been mentioning. It just does it for you. So that get method that was defined in the array list, it is written to access an array. So inside of the array list is an array. And then every time you add to it, the array list increases, will increase for you. So that code I showed you to double the size of the array, that exists inside the array list class. And then setting something in the middle and shifting everything over, that code exists in the array list class. So the array list just sits on top of an array. So you're using an array any way you look at it. It's just your interface is the array list versus the array. So the array list adds a level of complexity to your code, right? I mean, I don't know that I want to say complexity, but you're calling the array list that then is doing all the work that you would have had to do with the array anyway. So it definitely helps with errors and is a great feature because you know that Java has optimized all that, but it's an extra step. So using an array can actually be more efficient because you have direct access to the data. But then again, it's more complex because you have to take care of monitoring the size of your array and shifting things and doing all that. So if you have a situation where you know how many elements you're going to need so you can define that array to be exactly what you want, then an array is your better choice. But if you have an unknown number of elements, then an array list is your choice, is your better choice. So a great example is I actually live in Union County, and I think I've mentioned to you guys that I like to run, right? And so Union County has what they call the Union County Consortium, which is a series of races that they sponsor throughout the year. But it's a known entity, right? They know that there's going to be the pumpkin dash in November, and they know that there's going to be, these different runs that occur. So that's a known entity going in. And so there's like 10 races that they do. So that's an array because you know exactly how many races there are going to be. There's going to be 10 of them, and here are the races. It's a known entity going into it. But what's unknown is how many runners are going to sign up for each individual race. So the runners signing up for a race would be an array list because that's an unknown entity, where the number of races in the consortium is a known entity, so that's an array. Okay. Likewise, you could look at the course layout for like computer science. The courses that are in computer science is a known entity, so that could be an array. But how many students will sign up for each course is an unknown entity. So that would be better defined as an array list. Does that make sense? Great. So they both serve their purpose, even though array list by far is the student's more favorite of the two constructs. Okay, so let me just pull up the homework. Week 8. So what you're going to have to do is in week 7, you are writing the assignment mini lab, right? There's going to be lots of lots of things with the arrays and the array list that you used to see. But where you're going to go back is you're going to go back and make some changes to that assignment mini lab that you were creating in week 7. So in week 7, we just kept a running total of the scores, but we didn't keep track of each individual score, right? We just kept track of this is the total. As each score was added, we just added it to our total and bumped up our count. So what you're going to do instead now is you're going to actually store each individual score in an array. You're going to start out with an array, not an array list. Okay. So an integer array. We're going to start out with an array. And then we're going to have you rewrite it to become an array list. Now, and that's where I'm kind of like, I feel like I'm missing some of my slides here. Um, an array list will not let you store integer data, but it will allow you to store what's called a wrapper class. And I know we're going to talk about maybe wrapper classes are next week, but we cannot define an array list with int, but you can define an array list with capital integer. And so what this allows us to do is take our primitive data and convert it to an object so that we can use it in constructs like array lists. And there's other ones as well. It's just the one we're going to be dealing with is an array list. So if we had integer score array equals new integer like 100. Then if we were defining an array list, it would be an array list integer score array equals new array list integer like that. Okay, so it allows us to take our primitive data and convert it into object related data. The math class is probably looking for primitive data, but there's also what's called, and we'll get in more of this definitely next week or the week after, there's what's called auto boxing and auto unboxing. So I can definitely say, so let's say I have integer x equals 10, and I wanted to convert this to an object. I can do integer x equals x, and it automatically converts it back and forth from an integer class to integer primitive data for me. And then vice versa, I can also say integer equals object x here, and so this would take it from primitive data and automatically convert it to an object, and this takes it from an object and automatically converts it back to primitive data. So even though the math class may want the primitive data, it's very easy to convert back and forth from the object to the primitive data. But yeah, when you're working on this last class, this one here, where you have to make it an array list as opposed to an array, you'll have to define it like this to use the integer data. All right, but I just wanted to point out, because when we start this assignment, it definitely wants you to use an array. And some students are like, oh, but the array list is so much cooler. I want to use the array list, right? But we want you to start with an array and then switch to an array list. And the reason is for the whole black box and testing and encapsulation, right? You will discover that you will not have to change any of your test cases, that you're going to write your test cases based upon the first solution, right? And then you change it to be an array list, and you can run all of your test cases again without changing a single one, and they will work with your solution using an array or using an array list, which is a really cool feature. Java will not let you redefine a variable, so you cannot share variable names. No, so not like Python, where Python will let you redefine a variable from one data type to the next. Java will not allow that. So unfortunately, no. All right, well, this brings us to the end of arrays and array lists, random class, debugging. Do any questions come to mind? All right, I'm going to take that empty chat as no. Do not forget Lab 3. I went over Lab 3, geez, a couple weeks ago in the meet sessions. So you can go out and look to see which recording that was that I went over with Lab 3. It's definitely much more challenging than what you encountered with Lab 2, okay? It's involving classes inside of, objects inside of classes, inside of objects, inside of classes. So we're doing a bunch of nesting here, which requires a little bit more work and a little bit more effort. And so for those of you who have not heard my spiel, a couple of you guys have already completed your lab, right? So how many hours would you say that you invested into working on lab 3? So Dylan did a couple, but he's definitely a little bit more advanced maybe than some others. I would say that on average, students will invest about 10 hours on lab 3. Some more, some less. Oh, yeah. So, if things are really clicking for you, you may not find yourself investing that much time, but I just want you to be aware that lab 3 is going to require, or lab 3 could require, I guess, a significant investment of time. So if you can work on it at all this weekend, I would definitely encourage you to do so. Okay. All right. Well, that's all I've got for tonight. So you can certainly email me if you guys run any questions with the homework or lab 3, or you can post things out to Piazza. Um, Definitely Piazza is the better option because you get potential extra credit points that way. Other than that, that's all I've got. So have a great weekend, everyone.